welcome to my video today. My name is Corey Heisey, and I'm currently living in Germany in Deggendorf, which is in Bavaria. I'm studying my master's in mechatronics and cyber-physical systems. My undergrad is mechanical engineer, and today I'm going to talk about a bit about my observation in mechanical engineering versus mechatronics engineering. Now that I'm in the mechatronics program, and I've done the mechanical undergrad. So I've heard this before, and I've come to realize that mechatronics and mechanical are quite similar. So mechanical, my undergrad had, I would say probably maybe like 70%, 60-70% mechanical, and then maybe 15% electrical, 50% software, something like that. And because, I mean, you know, maybe mechanical 40 years ago was more traditional, what you'd expect from mechanical, but there's so many control systems. We had mechanical devices, electric motors and generators, MATLAB, robotics labs. And so my course now, so it's mechatronic and cyber-physical systems. And the cyber-physical systems, I didn't even know what it was at first, but it's just like interacting between cyber, so like virtual, and physical, right? So the real world. So it's kind of like has that theme throughout most of the courses, which is true. And then but I would more call it like, but it's nice for me because I have a mechanical undergrad, so it's nice. It's a great master's for me, and I'm really liking it. But I've seen some colleagues that are more thought it would be more software, more electrical, more of that kind of field. And so I think that's just, people really got to know that the mechatronics discipline isn't much different than mechanical, really, because like our courses, we have 3 courses right now on additive manufacturing, which is like cyber-physical system. You have like a virtual 3D model, and you're bringing it to the real world, you know, by 3D printing, for example. And but it's quite mechanical. Like we did all that too, and you know, this is more advanced, obviously, but we did manufacturing and additive manufacturing and all those courses. And then we have virtual reality and augmented reality, which is more of the cyber-physical systems, of course, but it's not. And that's, like I said, it has that topic of it. And then even like our robotics class last semester was like called robotics, but it was mainly just figuring out the position of the end effector, all mechanical, like dynamics and mechanics and all those calculations. Anyway, so I think I just want to say, if people are interested in mechatronics, you know, make sure that you realize that it might have more electrical and software than mechanical, but and have a better topic, because there's some topics that, like, I think a lot of people envisioned more embedded systems and microcontroller programming and developing, and I had that one elective, but that's the only course that seems to be here, and I took it and I really liked it. And we don't really have like electrical courses or anything. Like we had way more electrical courses in mechanical undergrad, but that's also because it's an undergrad, so you got to cover everything. You know, first year for everyone you have electrical and all those kind of courses. But anyways, it's great. I like it. So we have additive manufacturing, like 3 courses of those. One's case study, so it's like project work. One is, and then there's 2 other ones which are pretty similar. And then we have augmented reality, virtual reality course, which is like lecture and have individual research paper. And then we have an augmented reality, virtual reality case study. So it's a group project, big group semester-long project. And then we have another one, which is a mobile and adaptive human-machine interface, which is like on the same kind of topic of the virtual AR/VR classes. And that one's really interesting so far. It's like how the eye sees and stuff. It's quite, it's like psychology, but it's interesting. But it's tough because it's new. But that's the point, I guess. And yeah, so, but it's going good. Like I'm quite comfortable with additive manufacturing from personal interest in 3D printing too, which actually does help from day-to-day lectures compared to people that haven't done it on their own. And like I said, it's a great one difference though, I'd say, is that in my mechanical undergrad, me included, most of my colleagues and I, we didn't like to code. It was like, oh, I hate coding, or like MATLAB. Like we had this like weird stigma against, like, we didn't do it, or just it wasn't as good. And then I've had a self-interest in coding, and I wanted to do mechatronics because I thought, because I wanted to do more coding in a master's level, and I could do it with my mechanical undergrad. And there is lots of code, and it's more advanced than I know, and that's the whole point, obviously. But I definitely feel more comfortable tackling it now than I would have in the undergrad. And I think, and I haven't really heard from other people what their perspective on code to them is. But the code we do is way more mechanical though. Like we use MATLAB, or this new one, like I did a video on using ICE-SL, using code to make a STL file so you can slice it and use it into a 3D printer. So it's a quite mechanical code, which is great, right? So yeah. Anyways, enough of that. So, and yeah, I think that's going to be it for today, and until next time, bye for now.